Very warm good afternoon to all of you. This is Maria Pushpam, and today we are going to see carbon residue followed by gaseous fuel. And in gaseous fuel, we are going to see producer gas and water gas followed by calorific values. Hope you are able to follow the previous classes what I have taken. We have seen completely about solid fuels followed by liquid fuels and the test there, how to find the quality of liquid fuels. And in today's class we are going to see the last test in liquid fuel, which is said to be carbon residue, followed by producer gas, water gas, and its calorific values. Okay, I'll proceed with carbon residue. So, what do you mean by carbon residue is liquid fuels decompose at high temperature and form carbon deposit in the internal combustion engine, and this we call it as carbon residue. So, I'll repeat ma. So, what I mean by carbon residue is liquid fuels decompose at high temperature and form carbon deposit in the internal combustion engine. This we call it as carbon residue. ஸோ எந்த லிக்விட் ஃபியூலாக இருந்தாலும் அது ஃபுல்லாக எரிஞ்சதுக்கப்புறம் பேலன்ஸாக இருக்கிற அந்த வேஸ்ட் ப்ராடக்ட் வி கால் இட் இஸ் கார்பன் ரெசிடியூ. அண்ட் த ஃபியூல் இஸ் செட் டு பி குட் இஃப் இட் டெபாசிட்ஸ் லீஸ்ட் அமௌண்ட் ஆஃப் கார்பன் ரெசிடியூ. உனக்கு கார்பன் ரெசிடியூ வந்து மினிமம் வந்துச்சுன்னா அந்த that liquid fuel we call it as a good liquid fuel. Is it okay? And now we are going to see how to analyze this carbon residue. Carbon residue is analyzed by a method called as Contrassen's method. Contrassen's method. So what you have to do here is you take 1 gram of the liquid fuel in a silica crucible and weigh the crucible. You take a silica crucible, take 1 gram of liquid fuel and weigh the thing. You have to take the weight of the thing. After weighing, you close the crucible with the lid and you have to heat it in a sand bath. You should not directly heat. You have to heat it in a sand bath for about 15 minutes. After 15, what happens here is the oil in the crucible burns with a blue smoky flame. The oil in the crucible will burn with a blue smoky flame. And when the flame ceases, the crucible is removed from the sand bath. It is cooled and the desiccate and it's kept in a desiccator for cooling. After cooling, the thing is to be weighed. And from the difference in the weight of the crucible gives what is the amount of carbon residue in grams. I'll repeat the process ma. So what you have to do here is the method of determination of carbon residue is called as Contrassen's method. And what you have to do here is you take 1 gram of the fuel in a silica crucible which is previously weighed. Then what you have to do is you close the crucible with the lid and it is heated in a sand bath for about 15 minutes. After heating, during heating itself what happens there is the oil in the crucible burns with a blue smoky flame. As soon as the flame is being stopped, that is we call by the word ceases, the crucible is removed from the sand bath. You have to take the crucible from the sand bath. Then what you have to do is you cool the crucible in a desiccator for cooling. After cooling, you have to weigh the crucible. If you weigh the crucible, there will be a difference in weight from the first weight what we have taken and now the weight what we are taking. So this difference will give you what is the weight of the carbon residue present in the sample. Is it clear for you? So remind a point there. If carbon residue is found to be least, the quality of the fuel is found to be best. Is it okay? Next I'll go with gaseous fuels. So before going into gaseous fuels, we can have a recap of the thing what we have seen already. So in this unit we have seen previously solid fuel, and in solid fuel what are things we have seen is coal we have seen as a solid fuel. Then coming to coal, we have two sorts of analysis. One is called as proximate analysis, another one is called as ultimate analysis. After ultimate analysis, we have seen something about liquid fuels, and in liquid fuels we have seen mainly you know what liquid fuel is. Petrol, diesel, kerosene are called as liquid fuels. In this liquid fuels we have analyzed the quality of the liquid fuel. So the quality is being analyzed by four different things. One is called as flash point, followed by Unlin point, then octane number, and now in today's class we have seen something about carbon residue. I think it is clear for you. So now I'll move on to gaseous fuel. So you know what is gaseous fuel. Gaseous fuel is nothing but fuel in the gaseous form or gas form is called as gaseous fuel. Initially I have said you what gaseous fuel is. There are three types of fuels: solid, liquid and gas. Coming to gaseous fuel, we have natural gas, water gas and producer gas. In our syllabus we have only water gas and producer gas. So before going into this preparation and uses of water gas and producer gas, we can see what are the advantages of gaseous fuel compared to solid fuel and liquid fuel. Gaseous fuel is found to be more advantageous compared to liquid and gaseous fuel, and we can see what are the advantages here. First one is it will be having a high calorific value. So the calorific value of solid and liquid will be lesser compared to gaseous fuel. Second one, it will undergo complete combustion. Second one, it leaves no ash and the flame will be a smokeless flame. Next one is it is easy to transport, also it is safe to transport. Then coming to the thing, lighting is very easy as well as handling is also very easy, and burning can be easily controlled. We are using LPG and all in our homes. We know what happens here. Okay. So these are the main things you have to remember in mind. The advantages I'll repeat: high calorific value, complete combustion will go, no ash will be there, it gives a smokeless flame, and it is easy and safe to transport. Lighting and handling is very easy, and burning can be easily controlled. So these are the advantages of gaseous fuel. So now what's the thing we are going to see is we are going to see the preparation and uses of water gas as well as producer gas. Finally I'll conclude with calorific value. Okay ma. So now we can see what is said to be water gas. So all of us know what water gas is. Water gas is nothing but a mixture of carbon monoxide and hydrogen. We call it as water gas, and this water gas can also be called as blue gas. I'll repeat. So what do you mean by water gases? Water gas is a mixture of carbon monoxide and hydrogen. It can also be called as blue gas because it burns with a blue flame. Can you understand me? So I'll repeat. So carbon monoxide and hydrogen, the mixture is called as water gas. It can also be called as blue gas since it burns with a blue flame. Now we'll say what's the composition of water gas. The composition is found to be carbon monoxide 41%, hydrogen 51%, nitrogen 4%, carbon dioxide also 4%. So this is the composition of water gas. So if you see the composition, carbon and hydrogen will be 41 and 51, and if you compare this nitrogen and carbon dioxide, they are found in a very small amount, 4%. Is it okay? And the calorific value of water gas is found to be 2800 kilocalories per meter cube. Next one what we are going to see is how to prepare this water gas. Okay. So preparation is very simple. What you have to do here is it is produced by passing steam over red hot coke at 1000 degree centigrade. You take coke and you pass steam over red hot coke, and you have to maintain a temperature of about 1000 degree centigrade. In the previous class I have said you this what is coke. Coke is nothing but coal has to be heated in absence of air. So that process will produce you coke, and that coke has to be taken and it is heated to 1000 degrees centigrade, and you have to pass over that steam. Steam is nothing but H2O. So carbon plus coke is nothing but carbon. So carbon plus water gives you carbon monoxide plus hydrogen, and this we call it as water gas. It has many uses. We can see one by one. First use is it is used as an industrial fuel. Then it is you know what is industrial fuel. Then it is used as a reducing agent. In reduction process it is being used, reducing agent. Then it is used for the manufacture of ammonia, because ammonia needs, for manufacturing ammonia we are in need of nitrogen and hydrogen. This water gas will act as a source of hydrogen for production of ammonia. Then it's also used in the manufacture of methyl alcohol, also synthetic petroleum. Synthetic petrol. So these are the uses of water gas. I'll repeat the uses once again. For it is used as a industrial fuel, it is used as a reducing agent, then it is used in the manufacture of ammonia, where hydrogen is needed, and the source of hydrogen is nothing but water gas. And fourth one is it's used in the manufacture of methyl alcohol, also in the manufacture of synthetic petrol. So this is something about water gas. Next we can see what is said to be producer gas, its composition, preparation and uses. Okay. So next one is nothing but producer gas. So I have said you water gas is nothing but carbon monoxide and hydrogen. The only difference between water gas and producer gas is there it has hydrogen, here it contains nitrogen. Okay, so carbon monoxide plus nitrogen mixture is called this producer gas. I'll repeat. So mixture of carbon monoxide and nitrogen is called this producer gas. Now we can see what is the composition of producer gas. It contains carbon monoxide 30%, nitrogen 50 to 55%, hydrogen 10 to 15%, carbon dioxide 3 to 6%. I'll repeat the composition once again. So carbon monoxide 30%, nitrogen 50 to 55%, hydrogen 10 to 15%, carbon dioxide 3 to 6%. And coming to the calorific value, it is 1300 kilocalories per meter cube. And if you take the water gas, its calorific value is 2800 calorie per meter cube. Is it okay? So now we can see what is the how to prepare this producer gas. Preparation. What you have to do here is you take a coke, same coke you have to take, we can call it as incandescent coke, which is nothing but lightning coke. It's a bright pure coke. You have to take pure coke and you have to blow air over it at a temperature of about 1200 degrees centigrade. There in water gas production, we have taken coke and we are passing steam over it at 1000 degrees centigrade. Here you have to take same coke, but you have to blow air over it at temperature of about 1200 degree centigrade. And what is the thing reaction taking place here is this coke will react with air to give you carbon dioxide. Then carbon dioxide will again react with coke to give you carbon monoxide. Now what happens is carbon monoxide will react with the nitrogen which is present in air, because nitrogen is a incombustible substance present in air in a fixed proportion, which is nothing but 50 to 55% of nitrogen will be present in air always. It won't react with anything else. So this carbon monoxide combines with nitrogen to form producer gas. I'll repeat the preparation once again. So preparation is very simple. What you have to do here is you blow air over incandescent coke at 1200 degree centigrade. And what's the chemical reaction taking place there is carbon is nothing but coke combines with oxygen from air to form carbon dioxide. Then carbon dioxide reacts with coke to give you carbon monoxide, and carbon monoxide again reacts with air, the nitrogen present in air, to give you a mixture which is said to be carbon monoxide plus nitrogen, which is called as producer gas. Next we can see what are the uses of this producer gas. So first use is it is used as a reducing agent in metallurgical operations. You know what is metallurgical operation? I said you metallurgical coke is being produced. Yes. So for production of steel, iron, then lathe purpose, all those purposes, and many metals are being produced for many purposes. And those metal operations, we are in need of a reducing agent, and this producer gas will act as a reducing agent in metallurgical operations. And second one, it is used as a fuel gas in muffle furnace for manufacture of glass. Also, it is used as a fuel gas in open hearth furnace for manufacture of steel. Then it is used in the manufacture of alcohol and the manufacture of ammonia as same as water gas. There it is a source of hydrogen. Here this is source of nitrogen, and is also used as a fuel in gas engine. I'll repeat the uses once again. So it is used as a reducing agent in metallurgical operation, as a fuel in muffle furnace, used in the manufacture of glass, and is used as a fuel gas in open hearth furnace in the manufacture of steel. Then it's also used for the manufacture of methyl alcohol. It's also used in the manufacture of ammonia, where nitrogen is being needed, and that nitrogen is given by this producer gas. Finally, it is also used in fuel in gas engines. Is it okay? And last one in this unit we can see the calorific value of the gaseous fuels. So two gases we have studied. One is water gas, another one is producer gas. So coming to the, I have said you what calorific value is. Yes. So calorific value, if you take calorific value, the calorific value of this particular, if you take two gases we are taking, one is coal gas and one is producer gas, another one is called as water gas. Coming to these two gases, coal gas is having a calorific, producer gas is having a calorific value 1000. We have only 1300. Water gas is 2800 and coal gas it is 1300. Why this vast difference is, if you take producer gas, it is having nitrogen, which is said to be a non-combustible substance. Okay, so this is the main reason for low calorific value of producer gas. So calorific value depends only on the constituents present in the gases. So depending upon the if it is a good combustible substance, it will have a high calorific value is nothing but producing large amount of heat is said to be calorific value. So a good calorific value, if a fuel is having a good calorific value, it is said to be a good fuel. Is it okay? So comparing the calorific value of water gas and producer gas, water gas is found to be a better having a good fuel compared to producer gas. The main reason is it is having a high calorific value compared to water gas. It's okay. I'll repeat the same point once again, ma. So what I mean by calorific value comparison gaseous fuel is calorific value depends only on the constituents of the gases. That is, constituents means it should, if it is said to be a combustible substance, it will produce large amount of heat. If it is said to be a non-combustible substance, it won't produce large amount of heat. So you have to compare only on the basis of that. So if you take carbon monoxide and hydrogen, both are combustible substance, so it produces a calorific value of 2800 kilocalories. And coming to this producer gas, only one combustible substance is there, carbon monoxide. Nitrogen is not a combustible substance, so the calorific value is being reduced. So this is something about the comparison. And comparatively, if you see, water gas is found to have a high calorific value compared to producer gas. So we can have a recap of the thing what you have seen today's class. The first one we have seen is nothing but carbon residue. I have said you what is carbon residue. Carbon residue is nothing but it's a substance which is left behind while burning liquid fuels, and if carbon residue is found to be low, the fuel is said to be a good fuel, and it is determined by Carter-Anderson's method. And coming to the other thing what we have seen for today's classes, water gas and producer gas. Water gas is nothing but a mixture of carbon monoxide and hydrogen. Producer gas is a mixture of carbon monoxide and nitrogen. So we have seen how to prepare water gas, how to prepare this producer gas, and what are the uses. Finally, I have said you the calorific value of gaseous fuels. So with this I wind up today's class, and this unit is completely over, ma. Take care of yourself. Be conscious in studying. Continue studying. Thank you.